Right, so here's the second paper 2 that we're going to work through. The November 2020 paper. Grade boundaries, see there, sticking with the same grade boundaries. On this paper, of the selected questions that I think we can attack, there's 47 marks available to us, which would take us into the grade A if we manage to get everything right. Okay, so first page, formulas, we'll come back to that when we need them. Question 1. Carol has 2 fair dice. Dice A is a cube, it shows the numbers 1 to 6. Dice B is a tetrahedron, it shows the numbers 1 to 4. Carol throws both dice. What's the probability that she throws a 5 on dice A and a 3 on dice B? So what you have to do here is work out what all the possible combinations of numbers are going to be. And then I'll show you a quicker way. So dice A is a cube, so it shows the numbers 1 to 6. So dice A could have a 1 on it. And while dice A has got a 1 on it, dice B could have a 1, it could have a 2, it could have a 3, or it could have a 4. So there are 4 possible outcomes where dice A has got a number 1 and dice B changes. We then have to consider the same for if dice A had a 2 on it. 1, 2, 3, 4. Dice A could have a 3 on it. Dice A could have a 4 on it. Dice A could have a 5 on it. And dice A could have a 6 on it. So the number of possible outcomes is going to be 1, 2, 3, 4. Times 1, 2, 3, 4, 5, 6. There's 24 possible outcomes, and the number of possible outcomes where it's a 5 on dice A and a 3 on dice B is 1. There's only one way that's going to happen out of 24. The quicker way of doing that is if you spot in the same way as when we were working with probability tree diagrams. If you're using the word and, then you're multiplying. So the probability 5 on A and probability 3 on B would be the chances of you getting a 5 on A, which is 1 out of 6, and means multiply. The chances of you getting a 3 on B is 1 out of 4, because there's only 4 possible outcomes, one of which is a 3. So 1 times 1 is 1, 6 times 4 is 24. So that's the higher level way of answering the question, and is less work, but you can answer it in that more practical way of looking at it. The important thing is that you make sure you have all the outcomes there. So there'll be a method mark there for either 1/6 times a quarter or listing all your outcomes, and 1 mark for getting 1 out of 24. B. Asif has a biased 4-sided dice. Dice shows the numbers 10, 20, 30 and 40. Asif shows the dice once. The table below gives the probability of obtaining each number. What is the probability that Asif throws a 30 or a 40? Well, just like probability tree diagrams, and means multiply, or means add. So the probability of 30 or 40 will be 1/5 plus 1/10. And this is a calculator allowed paper, so we don't have to worry about messing around with equivalent fractions. We can just use our fraction button. 1/5 plus 1 fraction button, 1 over 10 equals 0.3, or as a fraction, 3/10. Method mark for adding your fractions, answer mark for getting it right. Question 2. In this question, assessed on the quality of organisation, etc., etc. Diagram shows two right-angled triangles, so I'm immediately thinking Pythag, trig, joined together along a common side. So we've got AB is 10.8, BC is 14.4, and CD is 24. Calculate the area of triangle ACD. You must show all your workings. So in order to work out the area of triangle ACD, area of a triangle is half base times height, but the base and the height have to be at right angles to each other. So if we're calling CD the height, then AC will be the base. So AC times CD. We know what CD is. I don't know what AC is, so I haven't yet got enough information to work out what that area is. In order to do that, I need to find AC. Now, I'm looking at this common side AC, and I can see it's in this other right-angle triangle, which I already know two sides of. So this now is going to be my Pythag. It's not trig because I'm not working with the angles. So using Pythag, AC, I know I'm going to have to square those. I'm trying to find the longest side because it's pointed at by the right angle box, so that's the hypotenuse. So I need to square these and add to get the longer side. So it's going to be 10.8 squared plus 14.4 squared, and then I need to square root it to get back to the sides. So I square that, I add them together, and that would give me the square on the hypotenuse. I don't want the square, I want the side, so I square root it. So AC is going to be the square root of the sum of the sides. If I was trying to find one of the shorter sides there, then I'd be doing 14.4 squared, take away 10.8 squared, all square rooted. So now I can do that maths, square root, and do this all in one go. 10.8 squared plus 14.4 squared equals 18. So I now know that AC is 18 centimeters. So the area of triangle ACD is going to be a half times AC, which I now know is 18, times the perpendicular height, which is 24. Put that in my calculator just as I've written it. 1/2 times 18 times 24, which is 216. And because that's area, and because this is the question where you're being marked for how you set out your work, make sure that you include the correct units. So there's 5 marks for that. There'll be 3 marks for the Pythag part of it, the method, the square rooting and squaring, and correctly adding and getting the answer of 18. Then there'll be 1 mark for half base times height, and 1 mark for getting the correct answer. And then the OCW part of it, the +2 would be for just writing area of triangle using Pythag, naming your sides, and consistent use of units. Question 3. A solution to the equation x cubed minus 5x minus 350 equals 0 lies between 7.2 and 7.3. Use the method of trial and improvement to find the solution correct to 2 decimal places. Now, more often than not, the exam questions work to 1 decimal place. Every so often they chuck in a curveball and ask you to find it to 2. But the method you were going to use is exactly the same. It's just you're working to greater degree of accuracy. So if it lies between 7.2 and 7.3, then one of our answers, or the answer, is going to come from 7.20, 7.21, 22, 3, 7.24, 7.25, 7.26, 7.29, 7.30. One of those is my answer, and I've now got to chase it down in the same way we were doing to one decimal place. So we'll start in the middle. X equals 7.25, and we've got 7.25 cubed minus 5 lots of 7.25 minus 350. Into your calculator, just as you've written it. Open bracket, 7.25, close bracket, shift x squared gives us the cubed, minus 5 bracket, 7.25 minus 350. That's negative. 5 minus 5.171 dot 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 dot. Don't have to write the whole thing out, because all we're doing is comparing that to 0 and saying too small. So if 7.25 is too small, then there's no point in trying any of the numbers that are less than it, because they would all also be too small. So I'm going to go 7.27. 7.27 cubed minus 5 lots of 7.27 minus 350. Remember, you don't have to retype all that, you can just use your cursor buttons. So 7.25 becomes 7.27, and that's also too small. So there's no point in trying those ones. So now I'm going to go 7.29. You could have chosen 7.28, doesn't matter. We're going to end up in the same place. Back on my cursor. 9. Positive. Too large. So if that's too large, no point in trying 7.3. Now I need to get this between two consecutive numbers to two decimal places. So I need to go again and check 7.28. That should have been a 9 there, shouldn't it? So 7.29. So 7.28 this time, cubed, minus 5 lots of 7.28 minus 350. So that's negative. Too small. So that's great, because that means that eliminates that, and I've got it down now to those two decimal place numbers, consecutive. So this is going to give me my first two marks. So x is either 7.28 or 7.29 to 2 dp. Method is for doing some evaluations to chase it down. Answer is for getting it to that consecutive pair. For the second two marks, we now have to go halfway between those two to test. So we draw a little diagram, 7.28, 7.29. We test by going halfway between those two, which would be 7.285. test using x equals 7.285. If this works out as a negative value, it means that everything between 7.28 and 7.285 is going to be too small, which means my answer is in this area, and anything in that area rounded to 2 decimal places is going to be that. If my value works out to be too large, that means I can eliminate all of those, and everything in this region rounds to 7.28. So 7.285 cubed minus 5 bracket 7.285 minus 350 equals. Pop in a 5 there. And pop in a 5 there. And that's positive. 19887, so on, too large. So I can ignore all that. All values between 7.28 and 7.285 round to 7.28 to 2 dp. So it's exactly the same method as all the ones we've practiced where we round into 1 decimal place. It's just we have to go to 2 and then the test to 3. Question 4a. Which one of the following options describes 2x plus 5y? An equation, a formula, an expression, an inequality, or none of these? Well, it's not equal to anything, so it's not an equation. There's no inequalities there, so it's not an inequality. It's not a formula, because if it was a formula it would equal something. You'd have 2x plus 5y equals L or something like that. So it's not a formula, it is in fact an expression. It's a piece of algebra that you can simplify. Well, actually, in that term, you can't simplify, but it doesn't. There's no more work you can do with it. Which of the following options describes 3x minus 2 equals 7? Well, that's an equation. It's not a formula. You've only got the one value. It's not an expression because you can get an answer. It's not an inequality because it isn't a bigger than or less than. So 1 mark for each of those. Data for different values of t is shown below in the table below. Calculate an estimate of the mean value of t. Okay, this is something we would have practiced for the numeracy paper. It tends to come up far more frequently on a numeracy paper than it does on a maths paper, but it can come up, and in this case it did. So this is where you need to find the midpoint. So you work out the mid value. Halfway between 5 and 0 is 2.5. And the reason that it's an estimate is because we don't know. We know there are 8 values between 0 and 5, but we don't know what they are. So in order to work out an estimate, we're assuming they would all average out at around 2.5. Halfway between 5 and 10 is 7.5. Halfway between 10 and 15 is 12.5 and 17.5. We then multiply the mid value by the frequency to work out the total for the data items that are between 0 and 5. So 2.5 times 8 is 20. 7.5, lots of nothing, is nothing. Very common mistake there is just to write 7.5, which would be 7.5 times 1. 12.5 times 7 is 87.5, and 17.5 times 5 is also 87.5. Just check, that's a 17.5 times 5, 87.5, 12.5 times 7. Okay. So 87.5 plus 87.5 plus 20. So when I add those then together, I get 195. Mean is the total divided by the count. The total is the sum of all the data values, which is 195. The count is how many data values there actually are, and you get that by adding up the frequency. So the count in this case is going to be 20. So we do 195 divided by 20 and get 9.75. So there'd be 1 mark there for seeing you using the midpoints. There would be 1 mark for the sum of the multiples of each, and then 1 mark for the 195 divided by 20, and 1 mark for the final answer. Question 6. In the diagram below, A, B, B, C and C, D are 3 sides of a regular polygon. The polygon has 15 sides. The length of each side is 8. The exterior angle of the polygon is x degrees, and BRC is a right angle triangle. So I'm seeing right angle triangle. I've already used my Pythag skills, so this is almost certainly a trig question. Calculate the length of BR. Now this is a tricky trig question because before you can do the trig, you actually have to use angle properties of a polygon. Now, when you've got a regular polygon, the exterior angles all add up to 360 degrees. If I just quickly show you, let's say a regular pentagon. If you imagine that you start there and you're looking out in that direction, you're going to turn through an angle. If you then walk to there, you're looking in that direction, and then in order to walk around the path to get back to the start, you need to turn again. And because this is a regular polygon, every turn you make is going to be the same size. So walk to there, and there, and back to the start. So because you're then back to the start, you've actually turned through 360 degrees. And I know that on a 5-sided shape, I've got 1, 2, 3, 4, 5 turns. So to work out the size of the exterior angle, it's 360 divided by the number of turns you make, which is the same as the number of sides. So number sides. So x in this case is going to be 360 divided by, and the polygon is 15 sides. So 360 divided by 15 is 24 degrees. So that's what's unfair about this question, is if you haven't covered or you can't remember angles of a polygon, you're not going to be able to access the trig part of it. So that's 8, B, that's 24, R, C. You want to work out BR. So you want to find this one. So we name our sides. This is the hypotenuse, because it's being pointed at by the right angle. Opposite and adjacent. And in this case, it's the adjacent that we want to find. So if we just bang out our SOHCAHTOA, and we want to have the adjacent in it, because it's what we're trying to find, and have the hypotenuse in it, because we know it, hopefully we can see that the only one that links adjacent to hypotenuse is cos. Cover up what you're trying to find, which is the adjacent. So the adjacent is cos times hypotenuse, they're on the same level. So adjacent is is hyp times cos. Cos is always the angle, so that's going to be 24. So adjacent is BR, what they want us to find. Hypotenuse is 8 times cos 24. You may have written that as cos 24 times 8, absolutely fine, doesn't make any difference. So on your calculator, 8 times cos 24, close bracket, 7.3 centimeters. There's no instruction to round it. If you'd have written 7 there, because that was rounded to the nearest whole number, that would be fine. So you'd have a method and an answer mark for getting the 24, and then a method and answer mark for correctly choosing cos and writing that part of it, or cos 24 times 8, and 1 mark for your final answer. What I would suggest in a question like that is, if you didn't know how to find that exterior angle, but you felt then you could, if you knew it, go on and answer the trig part of it, then just estimate that. Just say, can't remember how to work it out, but if x was 30 degrees, or if x was 20 degrees, this would what the answer would be. And then they would follow through and you would still be able to get that set of 3 marks. Calculate the value of 3.2 times 10 to the 7 times 8.3 times 10 to the minus 2. So it's calculator allowed paper. So your standard form button is this one down here. So we can type that in exactly as we see it. So open bracket, 3.2, and then the times 10 to the power of 7 is that button, and then 7 multiplied by 8.3 times 10 to the negative, okay, not subtract, negative 2. Press your answer, and we've got 2656000. That's 1 mark. Give your answer in standard form. So that's going to be 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6. So the first part of standard form is a number between 1 and 10. You're working with the most significant part of the number, which is the 2. So it's going to be 2.656 times 10 to the power of 6, because that's in the power of 6 column. Question 8. The lengths of the sides of a rectangle are given as 24 and 15. Each measurement is given correct to the nearest centimetre. So it's a rounding question. Grade B, you need to be aware of that if the math seems too easy. So I've got that's going to be 24, that's going to be 15. Calculate the difference between the greatest possible perimeter and the least possible perimeter of the rectangle. So 15, if it's been rounded to the nearest centimetre, then its upper and lower limits are going to be 14.5 and 15.5. Okay, and we've gone over many times now why we're not going to use 15.4 or 15.49 recurring. We use those as the two extremes. And then for 24, similarly, it could be as big as 24.5 or as small as 23.5. Now the perimeter of that rectangle is the total distance all the way around. So for that perimeter to be as large as possible, you want those measurements to be as big as possible. So it's going to be 24.5 plus 15.5 plus another 24.5 plus another 15.5. So we've got 24.5 plus 15.5, 24.5, 15.5. 80 centimeters. So if those actual measurements were as large as they possibly could be, the perimeter could be 80 centimeters. For a small perimeter, then I'd have 23.5, 14.5, 76 centimeters. So calculate the difference between them. Difference between them would be 80 minus 76, which is a 4 centimeter difference. So there'd be 1 mark there for seeing you correctly working with the upper and lower limits, 1 mark for getting the perimeters maximum and minimum correct, and 1 mark for working out what the difference between them are. Question 9, simultaneous equations. So label the 2 equations that you start with. Step 1 then is to make the x's the same, and we do this by multiplying the first equation by 7 and then the second equation by 3, so you end up with both of them having a 21x. And we just keep track of what we're doing by just writing little notes. So equation 1, it's in a circle, multiplied by 7. 7 3s are 21, minus 2 7s 14y equals 14 times 7, 98. And we'll call that equation 3. Then we take equation 2 and we multiply it by 3 to get 21x plus 9y equals 75. So 3 lots of 7 is 21, 3 lots of 3 is 9, 3 lots of 25 is 75. So that then means that we can eliminate x from our equation by subtracting. So we're going to do equation 3 take away equation 4. 21x take away 21x, gone. Minus 14y take away 9y is going to be minus 23y, and 98 to take away 75 is 23. We want to get the y on its own. 20 minus 23 is joined to the y by a times, so I have to divide by minus 23. Means I've got to divide this side by minus 23. That will give me y equals minus 1. 23 divided by 23 is 1. Plus divided by a minus. Answers that the signs are different, the answer is negative. So y is 1. So that gets us 2 marks. 1 mark for getting it down to minus 23y is 23, eliminating the x. 1 mark for then getting it correct. And then for the second pair of marks, we then plonk this back into one of the equations we're given. Substitute in, and I'm going to put it in equation 1. So 3x minus 2, and then instead of writing y, I know that y has the value of negative 1 equals 14. 3x, 2 times 1 is 2, minus times a minus is a plus. I need to take 2 off both sides to get the 3x on its own. And then to get the x on its own, I need to divide by 3. When I do 3x divided by 3, I get x. When I do 12 divided by 3, I get 4. So the third mark is for substituting your calculated value back into an original equation, and then your fourth mark is for then solving that equation. So that's question 9. Question 10 we can't do. Question 11 we can. It's an indices question. Write 16 in to the power of 100 in the form 2 to the power of n. So I need to get 16 as a power of 2. Well, I know that 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16. 2 times 2 times 2 times 2. 2 2s are 4, 4 2s are 8, 2 8s are 16. So instead of having that 16 there, I can write it as 2 to the power of 4. Now, one of the rules of indices that we practiced back in January was that if you're raising a power to another power, you multiply that. So that becomes 2 to the power of 4 times 100, which is 2 to the power of 400. That's the final answer. There's one mark there for replacing 16 with 2 to the power of 4, and one mark for then correctly simplifying. Question 12 we can't do. Question 13 we can. So when you're factorizing with an x squared, you know, you should know, you're probably going to end up with double brackets. Now in this case, to do that, you need to put an extra step in where there's no x term. So it's going to be 4x squared plus no x minus 81. Then you have to do 4 times 81, which is 324. Okay, so this is a bit tricky now. You're looking for your common factors, your factor pairs of 324 that have got to add up to 0. So 324 divided by 2 is 162. Does 3 go into 324? I don't know, let's try it. Yes. Does 4 into 4, 81. 5 won't, because it doesn't end in a 0 or 5. 6 does. 7 doesn't. 8 doesn't. 9 does. 10 doesn't. 11 doesn't. 12 does. 13 no. 14 no. 3 2 4. 15 doesn't. 16 no. 17 no. 18 yes. And there we've got our choice, which is going to give us, Cass, can you get that? Which is going to add up to 0. So for it to add up to 0, we're going to have a positive value and a negative value. So 4x squared plus 18x minus 18x minus 81. So we rewrite it with, instead of the 0x, the plus 18 and minus 18. Cover up, you're looking for what you can take out of there as common. You can take a 2 out and an x out, leaving you 2x plus 9. You're then working with this one, and you know you've also got to end up with 2x plus 9. So I can take 9 out. 9 2s are 18, 9 9s are 81. But I've got to get the right sign there. If that was positive, I'd end up with positive values there, so it must be negative. So I've got my repeated bracket, and leaving me 2x minus 9. So it's 2x plus 9, 2x minus 9. There's another way to do that, but I didn't teach you that. I wanted to remain consistent. So you only had one method to learn. But it does make it a bit harder because you've got to write that plus 0x in. B, we don't have to do that. So this is now a repeat method. So 7/8 of 56. Write my factor pairs of 56. So 1 and 56, 2 and 28, 3 into 56. No, 4 into 56. 14. Okay, now I'm looking and I can see that I'm looking to make 10, and I can make 10 out of those two. So I don't need to list them all. I found one that I can use. So that's the one. And to get that, I'm going to have 7x squared, and then instead of plus 10, I'm going to have plus 14x minus 4x minus 8. 14x take away 4x is 10x. Work with the first pair. I can take a 7 and I can take a 7x out. That would leave me x plus 2. Check it. 7x times x is 7x squared. 7x times 2 is 14x. That means that this must have an x plus 2 as a bracket. I can take 4 out. That will give me 4x plus 8. I don't want 4x. I want minus 4x. So x plus 2 is the repeated factor, leaving me 7x minus 4. Hopefully you've practiced enough of those that you're really comfortable with those now. This is a bit sneakier, but it's a bit like what we do at that stage. We're looking for what's common there and there. And I can see that I've got an x plus 2 all squared, which I can take out of there and there, which would leave me x plus 2 in that one, and out of this one just a plus 5, because both x plus 2's have been taken out, which would be x plus 2 squared bracket x plus 7. So for this one, 1 mark for 2x plus 9, 1 mark for 2x minus 9, because you can just write that down if you spot that you've got what's called a difference of squares. It's going to be the square root of 4 is 2, the square root of 81 is 9. For this one, there'll be 1 mark for the method and 1 mark for the right pair. And similarly here, 1 mark for recognizing you can take x plus 2 squared out as common, and 1 mark for the final solution. Now for us, the only one of those out of those 6 marks that I would be disappointed if you didn't get is part B. You should get part B right and get those 2 marks. If you manage to get A and C right, then that's really, really pleasing. Question 14. Is an enlargement. It's in the second half of the higher tier paper, which means it's the negative scale factor. In the following diagram, triangle ABC has been enlarged to triangle DEF with the center of enlargement at O. So in this one, we don't need to find out where the center is. They're telling us it's there. If they hadn't told us, if you remember, we'd be joining the corresponding sides together and find out where all the lines intersected. So it's just a scale factor. You can see it's been reduced. We're taking this larger triangle down to a smaller triangle, and AB is basically DE in the enlargement, so it's gone from 4 squares to 2, so the scale factor is a half, but because it's also been inverted, that means it's a negative scale factor. So it's minus a half, and you want to be looking for that. It didn't come up in paper 1, it's going to be there in paper 2. Question 15 isn't one that we've covered. Question 16, 17, 18, 19 is the last one that we can do. Now this says use the quadratic formula to solve that equation. The quadratic formula you're given. Okay, so you can go hunting this. This is in one form or another. We know this is coming up on the paper. Okay, so this is the information for the quadratic equation formula. It's actually telling us here to use it. If it didn't, the fact that the answer is correct at 2 decimal places is the trigger that, all right, I need to go and use that. Now, in order to use that, I have to take my 5x plus 3, 5x minus 3 equals 19x, and I need to get it in the form of a number squared, number x squared plus number x plus a number equals 0. It's not in that form yet, which means I've got a bit of work to do before I can use the formula. So we get rid of the brackets. That's FOIL. First, 5x times 5x, 25x squared. 5x times 3, 15x, positive times a negative, signs are different, answer's negative. 3 times 5x, 15x, positive, positive, signs are the same, answer's positive. 3 times 3 is 9, positive times negative, signs are different, answer's negative. And I know that this has to equal 0, so I want to take the 19x off that side, which means I've got to take 19x off this side as well to make that 0. So that part of it comes from expanding brackets. The minus 19x comes because I need to make it equal 0. So I've taken 19x off both sides. Okay, let's see what I can do to tidy this up. There's only one x squared term. Minus 15x plus 15x is 0 x's, but I've got a minus 19x there. Take away 9 equals 0. So now I've got it in the form ax squared plus bx plus c, where a will be 25, b will be minus 19, and c would be minus 9. So using the formula, x equals minus b minus 19 plus or minus square root of b squared minus 19 squared minus 4 times a times c, all over 2 times a Let's tidy up. Minus minus makes a plus, so that's going to be 19 plus or minus the square root of minus 19 squared. Well, when you square something, it's just going to become positive, but if you want to check that, make sure you use brackets. 361. Then here, I've got minus times a minus is a plus. 4 times 25 is 100 times 9 is 900, and 2 times 25 is 50. Now, when I've done video clips on this in the past, what I've pointed out to you is that you can't take a square root of a negative number. So if you muddle up your signs there, and you end up with 361 take away 900, when you go to take a square root, the calculator will give you an error. And when you give you that error, go back and check, oh, that should be minus times minus is a plus. So I can go one more step here. 361 plus 900 is 1261, all divided by 50. At that point, I can't simplify that any further until I break up this plus or minus. Remember, when you're solving a quadratic equation, you tend to get two solutions. You get the either x equals 19 plus the square root of 1261 all over 50. We want our answer to 2 decimal places. Put it on your calculator exactly as we've written it. So use the fraction button on the top. We've got 19 plus 1261 over 50. So to 2 decimal places, 1.09. Or we say x equals 19 minus the square root of 1261, all divided by 50. And we don't have to retype that. We can use our cursor buttons, bimble into our formula, delete the plus, replace it with a subtract, and equals, and that one's going to be minus 0.33 to 2 decimal places. So although that looks like a lot of work, most of it is quite repetitive. If you practice solving quadratic equations using a calculator, that's a nice 5 marks, although they have made a little bit more work at the top there. So where are those 5 marks going to be awarded? You're going to get 2 of them for getting simplifying what you start with to get it into the form ax squared plus bx plus c. There'll be a method mark for correctly substituting everything into your formula, an answer mark for getting it down as simple as you can before breaking out into the 2 different solutions, and 1 mark for getting both of those correct. So that's it. Those are my solutions. The question 20 we haven't covered. So that's my solutions for that paper. Hopefully you've done all right in it.